Dear Professor, thank you for your time to review my presentation today. And the topic of my presentation is the design and implementation of mask-wearing recognition system based on YOLO 5. I will present my results from 4 aspects, including background, introduction, and related research status, technology introduction, objective design and implementation of projects, and then the conclusion. And the first thing I want to show is the introduction and background of the project. The original intention of this project is to combine the most popular technologies and most concerned issues to design a tools can be developed and used continuously. As for the technical part, I want to use is machine vision in machine learning. Machine vision is a rapidly developing branch of artificial intelligence. It's to use the machine instead of human eyes to make measurement and judgment. Machine vision system mainly consists of 3 parts: image acquisition, image processing and analyze, image output and display. It began in mid-1960 with American scholar robot research. But today, machine vision has received extensive attention and rapid development. However, one of the most important and most common application in machine vision is object detection. It's also the technology I want to use in my program. Object detection has been widely used now, such as face recognition, intelligent transportation, industry detection, and extra. Object detection has been developed for near 3 decades and it's developed very fast. From artificial feature extraction before deep learning to end-to-end model, it retrieved fast speed and low consumption now. So that's why I want to use this technology in my program. And for the most concerned issue part, I think is COVID-19 and monkeypox. In recent years, viruses such as COVID-19, influenza, and monkeypox has appeared in large numbers. Study has shown that most of human-to-human transmission of this virus is through droplet transmission. Well, an effective way to block the spread of droplets is wear mask. In public place, if both the transmission party and the infected party wear mask at the same time, the infection rate will be reduced to 4%. So wearing mask can effectively protect ourselves and others. And this project is merely to effectively detect whether people wear masks in public place. This can help managers of the public place to determine the risk factor in the current area and then determine whether to take effectively disinfection measure. Due to the issue of wearing masks is appearing recently, there is very few commercially available mask detection software on the market. And then I have investigated several open resource related projects, and they are basically based on OpenCV plus TensorFlow or the YOLO 3. I think YOLO 5 is definitely more accurate and faster than this method. So I think this is a project that can be continuously developed and used. In this project, in addition to YOLO 5 and the machine learning framework PyTorch, I also used OpenCV and PyQt technology in my program. This program called the function of opening camera and the process of video in OpenCV library. And since the front end is very simple, so I use the PyQt to develop a simple window. And why I choose YOLO 5 is because my objective is accurate, efficient, and usable. YOLO 5 is accurate, taking a public data set of bird recognition as an example. The accuracy increased from more than 70% to 19%. And then the second reason is YOLO 5 is extremely fast. The inference time is 0.007 seconds per image and 140 frames per second. Of course, it still has some shortcomings, but I think it's enough for my program now. And in terms of usability, my choice is YOLO 5S. For YOLO 5, whether it's 5S, 5N, 5L, or 5X, its backbone, neck, and head are the same. The only difference is the depth and width setting of the model. In the case of small data set, the speed and accuracy gap is not large, so 5S is the latest, is the best choice for my program. For design, I designed the 2-part 3 functions. Real-time video inspection are available for security personnel. In addition, if the environment is too complicated or the situation is very special, we can also cut a frame or small video of the whole video to review it in the tool. After we put the picture or video in, the detection result with the candidate frame can be output. Since I couldn't turn on the presentation camera and the mask detection camera at the same time, so I required the project introduction in advance. Now I can start it. This is the tool I used for labeled out picture in my dataset. It named label images. All the images are founded by public dataset, and this is the example of mask. I divided all the picture into 2 types, mask and no mask. And these pictures will be used by PyTorch later for machine learning. All the pictures will be put in the folder images, and the coordinate of these images will be put in image sets. I also need to change the path of this picture in train.txt, test.txt, and well.txt. And the configuration file like this mask YAML need to be adjusted too. The number of the class need to modified into 2, and the label of the class need to modified into mask and no mask. And the last step is train this model. Because the process is too long, so I already cut it off. We can see the result is the weight data in BestPT. And other results we can view and evaluate by these pictures, just like this MAP pictures. And this is the running progress. It can distinguish with hand and mask. And when I put down my mask, it can also be recognized. Due to the limit environment, the multiple player effect cannot be demoed. So multiple player effect can be reviewed as imported images. We import images here. And we can see the result here. It will be same if we import the video here. And this is all the function of my program. In conclusion, the mask wearing detection has achieved ideal results, and the mask can be distinguished from other objections. But in special conditions, if the detection object is too small or too dense, the system may fail to recognize the detection object. So if the system doesn't use in special occasions such as large-scale events or competition, is sufficient in daily public place and can be promoted and used. And I will also continue to improve this program in the future. And I think that's all the content. Finally, I would like to thank my professor for continued help and support. Thank you for your listening.